You think when you send a message, it travels as one piece, one complete thing from you to them. It doesn't. Every photo you send, every video you watch, every website you open is shattered, broken into dozens, sometimes thousands of tiny pieces. Each one takes its own path, across different networks, through different machines, sometimes even arriving out of order. And yet, on the other side, it all comes back together, perfectly. No missing words, no broken images, no half-loaded messages. So the real question is, how is that even possible? Let's follow the pieces. Imagine this. You want to send a 20-minute video to someone. Simple idea, right? Just send it. But here's the problem. The internet isn't a straight road. It's not one clean connection from you to them. It's a massive network of networks. Millions of devices, routers, servers. Connections constantly changing. If you try to send that entire video as one single piece, it would be too big, too slow, and too fragile. And if something went wrong, you'd have to send the entire thing again. That's not efficient. So instead, the internet does something much smarter. It breaks everything into packets. A packet is a small chunk of data, not random. Structured, organized, almost like a tiny envelope. Inside that envelope, you'll find a piece of your data, information about where it came from, information about where it needs to go, and instructions for how it should be handled. So instead of sending one giant file, you send 100 or thousands of little envelopes. Each one is small enough to move quickly, small enough to be rerouted if needed, small enough to survive a chaotic network. And here's where it gets interesting. They don't travel together. When you send data, those packets leave your device and enter the network. But from that point on, there's no fixed path. Routers, the decision makers of the internet, look at each packet individually. They don't care about the full message. They only see where this packet needs to go next. And based on network conditions, traffic, and availability, they send each packet in what they believe is the best direction at that moment. So imagine this. You send one message, packet goes left, packet 2 goes right, packet 3 takes a longer route, packet 4 gets delayed. They spread out, like cars leaving a busy city, each taking a different road, trying to reach the same destination. And that means something strange happens. They don't arrive in order. Some packets arrive quickly, others arrive later. Some take detours. And sometimes they don't arrive at all. They get lost, dropped, disconnected. Now think about that. Your message is literally arriving in pieces, out of order, with parts missing. And yet you never notice. Wow. Because something else is happening behind the scenes. Every packet carries more than just data. It also carries a number, a position. A way to say I am piece 12 of 200. I belong before this one. I come after that one. So when the packet arrives, your device doesn't just accept them. It rebuilds them, like a puzzle. It waits for the missing pieces, puts them in order. It requests anything that didn't arrive. Yes, if a packet is lost, the device literally says, send that one again. And all of this happens in milliseconds. Every time you send a message, watch a video, or open a website, this entire process happens. Silently, instantly, perfectly. Not because the internet is simple, but because it's designed to handle failure, to accept chaos, to work even when things go wrong. That's why it breaks everything into pieces. Because small pieces can survive a world that isn't perfect. And when you press send, you're not sending one thing. You're sending hundreds of tiny journeys, all trying to find their way. Next time you send a message, remember this. It didn't travel in a straight line. It didn't stay whole. It was broken apart, scattered across the world, and somehow found its way back together again. And that is how the internet really works.